This is SpaceTime, Series 23, Episode 26. And no, the world hasn't become even stranger than what it is now thanks to the coronavirus. But with everything that's happening and following loads of requests from our audience, we've made the monumental decision to move SpaceTime into a 3 shows per week format, with new episodes being broadcast every Monday, Wednesday and Friday. And if you're a SpaceTime Premium listener, you'll still get the entire week's episodes as a single commercial-free edition. Anyway, as they say in the classics, it's on with the show. And coming up on SpaceTime, the biggest explosion since the Big Bang. Could fragments of the planet Theia be buried under the lunar surface? And the growing number of near-Earth objects now being detected. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected the biggest explosion ever recorded anywhere in the universe other than the Big Bang itself. The massive blast has punched a hole 15 times the size of the Milky Way galaxy into the surrounding cosmos. A report in the Astrophysical Journal and on the pre-press physics website archive.org claims the record-breaking eruption is thought to have originated from a supermassive black hole in the Ophiuchus galaxy cluster some 390 million light-years away. Galaxy clusters are the largest structures in the known universe. They're held together by gravity and contain thousands of individual galaxies, together with dark matter and hot gas. A large galaxy with an active supermassive black hole in the middle of the Ophiuchus cluster is thought to have been the source of this explosion. Although black holes are usually infamous for pulling material towards them, they often expel prodigious amounts of material and energy as well. This happens when material falling towards the black hole is redirected outwards by magnetic field lines, forming powerful jets blasting into space at superluminal speeds and slamming into or through anything in their way. These beams, known as quasars, can be bright enough to be seen across the other side of the visible universe, making them among the brightest objects in the cosmos. The study's lead author, Simona Giacintucci from the United States Naval Research Laboratory in Washington, D.C., says the idea is to think of the blast in a similar way to the eruption of Mount St. Helens in 1980, which ripped the top off the mountain. Of course, in this case, it tore a hole right through an entire cluster of galaxies, each as massive as the Milky Way. Giacintucci and colleagues made their discovery using X-ray data from NASA's Chandra X-ray Observatory, the European Space Agency's XMM Newton X-ray telescope, the Giant Meter Wave Radio Telescope in India, and the Murchison Wide Field Array Radio Telescope in outback Western Australia. The Chandra observations, reported in 2016, first revealed hints of a giant explosion in the Ophiuchus galaxy cluster. Norbert Werner and colleagues first reported the discovery of an unusually curved edge in Chandra images of the cluster. They looked to see whether it could have been part of a wall in the cavity of the hot gas created by jets from a supermassive black hole, but ended up discounting the idea because of the incredible amounts of energy that would have been needed for a black hole to create such a massive cavity. However, Giacintucci and colleagues showed that such an enormous explosion did in fact occur. First, they showed that the curved edge was also detected by the XMM Newton Space Telescope, thus confirming the Chandra observations. They then used new radio telescope observations from the Murchison Wide Field Array and combined that with additional data from the archives of the Great Meter Wave Radio Telescope to show that the curved edge is indeed part of the wall of a cavity because it borders a region filled with radio emission. The emissions are being generated by electrons accelerated to nearly the speed of light by the black hole. The radio and X-ray data matched, providing the final proof for an eruption of unprecedented size. The amount of energy required to create the cavity in Ophiuchus is about 5 times greater than the previous record holder and thousands of times greater than typical clusters. The black hole eruption must have finished because the authors haven't seen any evidence of current jets in the radio data. The Chandra data shows that the densest and coolest gas has now moved away from the black hole, thereby depriving it of the fuel it needs to generate the jets in the first place and so shutting them down. The authors think this gas displacement is likely caused by sloshing of the gas around the middle of the cluster, sort of like wine sloshing around in a glass. Now, the merger of 2 galaxy clusters can trigger this kind of sloshing, but in this case it might have been triggered by the eruption. One puzzle is that only a single giant region of radio emissions is seen. That's unusual because these systems usually contain two such emission bulbs on opposite sides of the black hole. Now, of course, it's possible that the gas on the other side of the cluster from the cavity is less dense, and so the radio emissions there have simply faded more quickly. The study's co-author, Melanie Johnston-Hollett, from the Curtin University node of the International Centre for Radio Astronomy Research, says the findings underscore the importance of studying the universe at a range of different wavelengths.
Well, what it's been doing is what supermassive black holes tend to do, in that it's taking material in, but for some reason in this particular case, it's the amount of energy and material that it's ejecting, which is really quite astonishing. So this is the most massive and energetic outburst that we've seen from an AGN in the entire history of the universe, and it carved out a hole in the hot X-ray emitting plasma that surrounds the host galaxy, which is 15 times the size of our Milky Way galaxy. So pretty energetic. Very exciting.
Is this what we would call a quasar?
No, quasars are a type of active galaxy, so that's a particular classification. It doesn't actually apply in this case. So we would just call this a supermassive black hole, which is generating a radio galaxy. So you've got your normal large elliptical galaxy sitting in the center of a galaxy cluster, usually formed by cannibalism of smaller satellite galaxies, which are orbiting around the same center of mass. And at the center of that, there's a supermassive black hole. And we know that these supermassive black holes give out radio jets. So what happens is once they've reached a certain threshold of infalling material on an accretion disk, they produce very highly relativistic electrons embedded in magnetic fields coming out at right angles to the accretion disk. That's pretty normal. We see that there's literally hundreds of thousands of those in the universe. What's special about this one is the amount of magnetic fields and energetic particles traveling pretty close to the speed of light that this thing is emitting originally.
And it's punching a huge hole within the galaxy clusters that it's in the midst of.
Yeah, absolutely. So we know about 50 of these, we call them X-ray cavities in galaxy clusters, but this is the largest that we've yet seen and certainly required the most amount of energy to punch that hole. And what's really cool is that you can see the hole with the Chandra X-ray telescope, and then you can look at the same cluster with radio telescopes and actually see the radio emission, which is derived from a process called synchrotron radiation, where you have these energetic electrons spiraling in the magnetic field just filling that cavity. So we know exactly what it is, which is very cool.
Seeing this thing in such detail, what does this tell us about our understanding of the universe?
Well, firstly, it tells us that the universe is a stranger place than we thought it was, because in this particular case, a previous team had looked at this object with the Chandra X-ray telescope and seen this bubble, this cavity, and gone, oh, that can't have been caused by a supermassive black hole outburst because the energy would be ridiculous. So they actually put in their paper that it couldn't be that. So first of all, that's been changed. We've shown that it actually is that, and that these things can be energetic at these enormous levels. And secondly, I think for me, as a radio astronomer, probably the most exciting thing is that we've found this discovery because we have new low-frequency radio telescopes, which we haven't had recently. Well, we've had them in the last decade or so. And so there should be many more of these things. We should be able to find more of them with low-frequency radio telescopes. So I think those are the two most profound things that have come out of this discovery.
And of course, this is where the Australian angle comes into it all.
Yeah, so this is a big result for the Murchison Wide Field Array, which is a low-frequency radio telescope in the Midwest of Western Australia. It's on the site of the Future Square Kilometre Array radio telescope and is in fact one of the precursor telescopes to the SKA. And this particular object was actually seen with the MWA with a sky survey that we did between 70 and 230 megahertz called GLEAM. And this was one of the weirdest objects that I found in a catalogue of diffuse sources in galaxy clusters. And then my colleague Simona, who's the lead author on the paper, followed it up in more detail, and she went back and looked at archival data with the Giant Meter Wave Radio Telescope in India, which is also a low-frequency telescope, and was able to confirm that the emission that we were seeing with the MWA was also seen with the GMRT, and then that's where the whole thing led off from. So it's very cool.
Pretty spectacular.
Oh, yeah. Well, as director of the MWA and had someone who actually worked on this research, for me, it's like super exciting. So one, I get to actually say, look, isn't my telescope doing this amazing stuff? But two, I get to say, hey, this is cool research that I was doing in my own field of galaxy clusters. So yeah, it's pretty cool.
Where to next?
We're asking for more time on the X-ray telescopes. So we want to get more data to be able to look in more detail at the cluster and at the X-ray mission to go deeper. And we've upgraded the MWA since the observations were done. So we're going to look at it again, and we should have twice the resolution and more sensitivity, and hopefully we can see if we can understand a bit better some of the puzzles that are left with this particular object. So normally when you get these cavities, you get them in pairs, and you get the jets of supermassive black holes in pairs. In this particular case, we're only seeing one of these things, and we don't know quite why that is. Perhaps it's a projection effect, or perhaps the material on one side of the cluster is denser than the other. So there's a number of questions that we're trying to answer. So more data is what we really need.
More data, that's what every scientist says.
Yeah.
Indeed. That's Melanie Johnston-Hollett from the Curtin University node of the International Centre for Radio Astronomy Research. And this is Space Time. I'm Stuart Gary. Still to come, could fragments of the planet Theia be buried under the lunar surface? Astronomers are detecting more and more near-Earth objects, and later in the science report, growing calls for an international investigation into Beijing's cover-up of the true extent of the COVID-19 coronavirus. All that and more still to come on Space Time. A new study claims fragments of the planet that hit the Earth to create our moon may still be present below the lunar surface. According to the widely accepted giant impact theory, a Mars-sized planet, which scientists have named Theia, collided with the early proto-Earth 4.5 billion years ago. The massive collision melted both bodies into a magma ocean, which then slowly solidified to form the Earth, while debris ejecta flung into orbit from the impact coalesced to form the moon. The theory explains the formation of the moon very well, but there are a few niggling questions. One problem has been that oxygen isotopes in lunar rocks collected by astronauts during the Apollo missions are similar to those found on Earth, but very different from those found on other bodies across the solar system. Now, if the giant impact theory is correct, there should be some significant variation in the isotopes, which there isn't. Until now, the best answer has been that Theia and the Earth probably formed in the same part of the solar system, so the material from which they formed would be similar, and the conditions under which they formed would also be nearly identical. Problem solved. But not everyone's convinced. Now, a report in the journal Nature Geoscience claims researchers from the University of New Mexico believe they've found the remains of Theia buried beneath the lunar surface. They examined oxygen isotopes from a range of different lunar rock types, which were collected at different depths, finding that the deeper the origin of the rock, the heavier the oxygen isotopes were, compared to those found on Earth. Now, the authors suggest these observations mean the remains of parts of Theia could be there, buried deep below the lunar surface. Now all we have to do is go back there and find out. This is Space Time. Still to come, the detection of more and more near-Earth objects. And later in the science report, a new study claims Australia's mega bushfires were responsible for more than 400 deaths. All that and more still to come on Space Time. The European Space Agency's NearEarth Objects Coordination Centre has added another 202 asteroids to its list of potentially hazardous objects which pass close to the Earth. Now, that brings to 529 the number of near-Earth objects, or NEOs, discovered since the start of this year. It means there are now some 22,209 asteroids and 109 comets classified as near-Earth objects as of February 2020. That includes some 1,022 NEOs regarded as being of serious risk. Among these is a 200-metre-wide asteroid catalogued as 2013 XA133, which will pass within 17 times the Earth-Moon distance on March the 27th. 6 asteroids were detected passing closer to the Earth than the Moon's orbit over the past month. These included 2020 BT14, 2020 CQ1, 2020 CQ2, 2020 CW, and 2020 DR4, which all pass within 200,000 kilometres of the Earth's surface. While the captured asteroid 2020 CD3, a recently discovered temporary second moon orbiting the Earth, came within 40,000 kilometres of the Earth's surface during its last close approach. Although only recently discovered, 2020 CD3 is believed to have been circling the Earth for at least 3 years, ever since it was grabbed by Earth's gravitational pull. The 2 to 3.5 metre wide asteroid is on a highly elongated orbit which wraps around the Earth, then extends out far beyond the orbit of the Moon. It's only expected to remain in its present orbit for a couple of more weeks before being flung out of the Earth-Moon system and back into interplanetary space. Meanwhile, 2 new asteroids have entered the NEO risk list. 2020 DR2 is a 600-metre wide space rock first detected on February the 20th. Calculations indicate it has a 1 in 80,000 chance of hitting the Earth in 2081 and a slightly lower chance a little earlier in 2074. The even bigger asteroid, the 800-metre wide 2020 BW14, looked like a possible impactor in 2046 based on initial observations. Luckily, follow-up observations have now taken it off the risk list. This is SpaceTime. Russia has launched another 34 OneWeb broadband internet satellites into orbit for Arianespace. The ST23E26 mission, the third for OneWeb, was launched aboard a Soyuz 21B rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The satellites, numbered 41 to 74, were placed into a 450-kilometre high near-polar orbit. The flight comes just a month after the last Soyuz OneWeb launch. OneWeb hopes to have an initial constellation of 650 satellites, providing global internet coverage by the end of next year. Eventually, the company envisages having a fleet of 1,972 of the 200-kilogram Ku-band satellites orbiting the Earth. And time now to take a brief look at some of the other stories making news in science this week with a science report. There are growing calls for an international investigation into Beijing's cover-up of the true extent of the COVID-19 coronavirus. United States Senator Josh Hawley from Washington's powerful Senate Judiciary Committee says the Chinese Communist Party's actions have cost thousands of lives. COVID-19 has now infected around 500,000 people in 197 countries, killing some 25,000, with the World Health Organization saying the mortality rate is still around 3.4%, with males twice as likely to die as females. The most likely to die are those over the age of 80, who have between a 14.8 and a 21.9% chance of dying from the virus, while those between 70 and 79 have an 8% chance, those between 60 and 69 a 3.6% chance, and those between 50 and 59 have a 1.3% likelihood of succumbing to the disease. Your chances of dying from COVID-19 are also increased by more than 10% if you also suffer from cardiovascular disease, over 7% if you have diabetes, more than 6% with either hypertension or chronic respiratory disease, and over 5% if you have cancer. Meanwhile, the University of Western Australia has released data showing that social distancing measures such as working from home, self-isolation, and community contact reduction should be highly effective in reducing the number of cases of COVID-19. It found the two most effective social distancing measures were self-isolation and a 70% reduction in community-wide contact, which is defined as any social contact outside of school, work, or home. Researchers used computer modelling to evaluate how a range of social distancing measures could stop the virus from spreading, using the New South Wales city of Newcastle to model the spread. The first Phase 1 clinical trials of a potential COVID-19 vaccine have begun in Seattle, Washington. A report in the journal Nature claims the experimental vaccine relies on messenger RNA, which directs the body to make a protein found in the virus's outer shell, hopefully enticing an immune response that protects against infection. Over the next 6 weeks, 45 participants will receive varying doses of the vaccine, followed by a second dose 28 days later. They'll then be assessed over a 14-month period. Meanwhile, scientists are showing growing interest in two malaria drugs, chloroquine and hydroxychloroquine, which have already delivered some interesting results in the battle against COVID-19. However, while anecdotal reports are glowing, proper scientific trials are yet to be undertaken. New York, which has America's highest incidence of the COVID-19 virus, is undertaking trials of the drugs, procuring some 750,000 doses of chloroquine and 70,000 doses of hydroxychloroquine. Chloroquine is a derivative of quinine, which comes from a native South American tree and is used by locals to treat fevers. Hydroxychloroquine is a less toxic analogue with a similar chemical structure but different properties. It's used to treat rheumatoid arthritis, lupus, and the blood disorder porphyria. A new study has found that smoke from Australia's recent mega bushfires was responsible for over 400 deaths. The findings, reported in the Medical Journal of Australia, looked at the overall impact of the unprecedented wildfires which blackened wide areas of the nation. Researchers found smoke from the fires was directly responsible for 417 excess deaths, 1,124 hospitalisations for heart problems, and 2,027 for respiratory problems, as well as 1,350 emergency visits for people with asthma. The authors estimate that population exposure to tiny particles in the air in the eastern states of New South Wales, Victoria and Queensland, as well as the Australian Capital Territory, from the end of 2019 well into 2020. They found the smoke-related health impact to be substantial. The authors warn that smoke is one of the many problems that will intensify with more frequent and intense bushfire seasons, and more bushfire mitigation approaches are needed to reduce the health and safety risks. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.